All right, so welcome everyone. I'm Jacek. With me on stage here, Boris. We're both part of the research team at Status. Today we're going to be talking a little bit about the communication protocol that we use a lot for chat and so on. But before we do that, I wanted to talk a little bit about what Status is. I don't know how many here know about Status, more or less, right? It's kind of like this chat application, like Messenger, right? Like almost like WhatsApp, owned by Facebook and all that stuff. No, so Status is a messenger, but it's also meant to be more. It's like a gateway to the Ethereum world, meant to be used on mobiles and other resource restricted devices. So what we're trying to achieve is sort of bring this beautiful world of Ethereum with blockchain, with Swarm, with messaging as done in Whisper to the masses, right? So trying to sort of adapt it to what normal people would use in their everyday life. And that might include chatting with each other, but it might also include interacting with dApps, making financial transactions, running bots, you know, whatever you might think of as useful in the Web3 world, except that you run it on a phone, right? And that comes with some unique constraints. Let's put it this way. So I wanted to talk a little bit as well about how we came here. I know yesterday we had a great dinner. I've had a great time throughout all the talks. I'd like to thank you all for it. And one question that I got asked was like, what's it like to work at Status, right? Because I just joined, that's all like fresh in my mind. And so we're a fully distributed company. We're about 70, 80 people now, I guess, growing pretty extensively. Distributed company or work from home company means that all of us are spread out all over the world. Like I'm in Singapore, this guy is in Moscow, there's like a big bunch in Berlin, a couple in the States, in Brazil, it's like spread all over the place, which comes with some unique challenges as well, but it's just an interesting place to be. And why would anybody want to join a company like that, right? It's kind of weird, like with all the ICO scams going on and so on. Something in particular must have struck a particular note with the people here, right? And for me personally, this journey kind of started in the early 2000s. Being in Sweden at that time was pretty interesting. The Pirate Bay debacle was going down. There was a lot of enthusiasm about peer-to-peer networking, about information wanting to be free, about how to build a different digital world, right, out of the pieces that we had back then, which were much, much more primitive than they are today. So just a quick straw poll here, like who knows of Napster? Like who's used Napster? Sorry, not knows of Napster, used Napster. All right, a good bunch, right? Direct Connect, a little bit less. Still peer-to-peer, right? These technologies, they basically they changed the model from there being a server like FTP or IRC or whatever to enable you to transfer files directly between peers, and this was like a great thing. The other great thing that went down back then was the Cord paper, which was like the start of distributed hash tables, you could say, and then later on Kademlia came on top of that, right? And that was like this beautiful revelation, right? That in logarithmic time you could reach any computer out there, basically. And it married two fairly simple concepts, right? It married connecting to a few peers, where all the peers have equal responsibilities, together with binary search. It's like, if you look back at it now, it's so trivial, if you explain it that way, right? But back then it was really cool because all we had was like, you know, star formations of distributed systems and maybe these peer-to-peer systems, but they were incredibly inefficient in all kinds of manners and ways, right? After that came BitTorrent, and that was like another big revelation, right? They put an incentivization layer on top of that peer-to-peer system, so away with private forums and sort of having to prove that you're uploading, and suddenly it was just in your interest to provide the same data as you were interested in. Obviously very limited in scope, it was very specific, like you're interested in this file, you get this file back, and that's it, right? And after that was a little bit of a lull in the peer-to-peer space. What happened was cloud computing and all that stuff. Sure, interesting, but not so interesting for me in particular. Why I'm mentioning all this is that all these technologies, they were made, what, 15 years ago? And today we're seeing an explosion again in interest in how these technologies that were developed back then, how they can be combined today with new things, new ideas, and to build something yet more interesting, right? And solve some of these problems that we were unable to solve back then. So that got me thinking, right, that the stuff that we're working on today, it's also kind of base layer. It's also very low in the stack. Like Ethereum, that's like general payments, and then on top of that, people build all kinds of fantastic dApps and use it for their own purpose. Same thing with something like Swarm. That's, in many ways, that's kind of like a generalization of BitTorrent, if you think about it. Like you can dump files in there, and you can get some kind of reward for it. And instead of bartering file for file, you introduce like an economic money concept, which sort of decouples one thing from the other, right? And what I imagine is that the technologies that we do today, right, in 20 years from now, they're going to be combined with something else and bring yet more interesting ideas to the world. And where does that put me? That puts me in a spot where I have a great responsibility to put stuff out there that's good, that makes sense, that promotes the right things. And in my case, I believe that decentralization is in general better than centralization, right? So that's how I come into this space, and that's kind of thinking that goes around in my head, like, am I doing something useful? Because the stuff that I'm doing now is probably going to be useful in 20 years from now, hopefully, right? That's my great assumption here. Even if my contribution is tiny, tiny, tiny like this, it's still a contribution, right? And I have to make a choice. What am I going to contribute to? Am I going to contribute to yet another centralized service? Am I going to contribute to something which is, I don't know, used for, say, military purposes or whatever it might be? Or am I going to promote something or work on something which promotes sane behavior? And that leads us into our topic, right, which is about Whisper. And I'm soon going to leave the mic over to Boris here, who's going to give you a great talk on like the technical details of it. But Whisper is one more of those technologies that I feel good about working on. It increases privacy in the world. It gives people an opportunity to communicate with the people that they want to, excluding the people that they don't want to. It promotes a world where censorship becomes more difficult. At the same time, it's terribly inefficient, so that's something we just need to fix, right? But these underlying ideals are the underlying ideals that built the internet once upon a time, right? Where every node would be equal, and you would be sending on bits to the guy next door and hoping that eventually they would get there. And Whisper is very, very similar in this aspect. It's yet another of those technologies that allows this unrestricted communication between people and without any central point of failure. All right, Boris.
Hello. I'm talking about... Hello? Yeah. Okay. So what is Whisper? Whisper is a protocol of Ethereum. It's... Closer? Okay. It's a protocol of Ethereum. It allows to achieve 100% of darkness. It's the main property of it. So Why do we need Whisper? We suppose that status users need Whisper to have more privacy in our world. So Whisper is kind of probabilistic gossip protocol. We can't understand what messages are interested in by a user because each node receives every Whisper message. So we use Whisper in status for several purposes. We use it for message exchanging, for message moderation, and we're going to use for DApp communication. Message peer-to-peer communication in Whisper network using DFTP underlying protocol, and it don't use blockchain at all. So theoretically, Whisper could be used for all networks and networks ID, and theoretically could be used for all Ethereum forks. Whisper now, some brief information about Whisper. Whisper communicate with other Whisper nodes using envelopes. Envelopes has message included and some information for communicating between nodes, like POV information and the topic. Message contains message you want to send. Filters is used for decrypting the message. So if you receive the message, you try to decrypt it, and you have key to decrypt it. You could send it to user, but it's not efficient to decrypt all messages, and we have topics for understanding which messages we need to decrypt. So it allows us to keep balance between privacy and performance. So collisions in topics not only expected they are necessary because we want to achieve darkness. When we use Whisper v5, we have in our application, we have from 10 to 20 gigabytes of data per day. It's too much for mobile application. So we have to migrate to a new version of Whisper. It's Whisper v6. The main goal is trade-off between keeping darkness and traffic reduction. Whisper v6 introduces two main concepts. It's bloom filter and light mode. So when we create new filter, topics from the filter add some bytes to bloom filter, and this bloom filter sends to connected Whisper peers. So you receive only messages from which matched with this bloom filter, and you don't receive unused messages. The second concept is light mode. You receive messages, but you don't send these messages to other connected peer. It allows us to reduce traffic too. Bloom filter has many collision per topic because we want to achieve darkness, and it allows us to improve our performance and not share user topics which are interested in. Whisper has mailbox concept. So mailbox is a generic Whisper node which collects all Whisper messages. It works as Whisperified node, but if you miss some messages, like your application was offline or network connection problem, you could request these messages from mailbox. You send your own Bloom filter with topic you are interested in, and you need to say it from and to fields. It is timestamp, and mailbox send this message to you directly. Whisper has two types of messages. It's direct Whisper messages and generic Whisper messages, which use Gossip protocol to communicate with other peer. So mailbox interface is pretty simple. The current implementation of mailbox is simple. It contains 500 lines of code, but it was good. So this is an example how Whisper message is go through the Whisper network. For example, light node said the message to connect to peer, and from this node it sent to all connected peer of these nodes. But as you can see that we have some light nodes like phones, and they don't send to other nodes the messages. In our case, when I started working in status half a year ago, we had no persistent messaging. We have huge network consumption, like 10, 20 gigabytes per day, and CPU usage is high. So after the changes, we dropped CPU usage to 10, 20 gigabytes per day. We reduced CPU usage twice, and we have persistent messaging. So I think Jacek said about next steps.
Yeah, so thanks, Boris. Excellent overview. We still have some problems to solve with Whisper, obviously. And this is a topic of ongoing research, right? So when we look at Whisper, obviously we're using it for a particular purpose. It might be messaging, and as Boris mentioned, it might be dApps talking to each other, it might be group chat and so on. And all that happens, a lot of that stuff happens in the application layer, like how do you encode a payload for Whisper messages? How can we promote interoperability with other users of Whisper or other transports underneath, like maybe PSS in the future, right? So a lot of the things that we'll be looking on in the future will be like the security properties of the application layer. And for chat in particular, that might be the privacy properties that you gain by using certain protocols such as double ratchets and these key exchanges, and whether you get forward secrecy or not, what kind of anonymity you offer or not, what kind of guarantees can you give the user? Do you give the user a sliding scale of privacy, or do you just give them like one option? And obviously these are areas that we're looking to cooperate with the community eventually, right? Because it's a messaging app. It doesn't make sense to build a messaging app in a vacuum, right? It needs to communicate with other people.
Other messaging apps.
Yeah, there's a lot of them, right? But I don't mind there being a lot of messaging apps, but it's nice if they can talk to each other.
Talk to each other is what I'm saying.
Yeah. Sorry?
The messaging apps should talk to each other.
Yeah, exactly, right? Well, of course they have tried, and we're going to make another try because now we're right. No, but these are like areas that we're interested in furthering, right, and in seeking some kind of cooperation with the wider community, because the problems that we'll be solving in the application layer are going to be seen everywhere. Like, we need to exchange contacts, we need to exchange messages, we need to exchange keys, we need to do all these operations just like everybody else, right? So this is like one of the 3 areas that we're looking at to improve on top of what we're doing today, right? So application layer is the first one. As far as the protocol itself goes, Whisper, right? Obviously, being a mobile client, we're always interested in bandwidth management of all kinds and shapes and forms. The work that we managed to do between V5 and V6 was great, right? But then, as the number of users grows, we might want to make sure that decreases even further. One thing that is a little bit worrisome with all these Ethereum protocols is that their lifespan so far has been pretty short. And Whisper, being sort of the bastard stepchild of Ethereum a little bit, hasn't received any attention, and because it hasn't received that much attention, it hasn't received much analysis either from a security point of view, like how do you break it? If you think about Tor, when it came out, right, onion routing, everybody was happy because like, oh wow, finally we can get anonymity, and then it turned out that if you were able to control X% of the nodes around the guy, you could figure out pretty much anything. And then a few years later, they noticed that, all right, maybe it's not even that many percentage of nodes, but you can dox people pretty nicely. And this kind of security analysis, like I've searched and scoured the web for anything related to how to break Whisper, and it's really hard to find. And I guess that defines Swarm at this stage as well, because it doesn't even exist, right? And PSS and so on. Like, how well battle tested are these protocols? Yeah.
They actually published it in proceedings of privacy. So when Tor came out, and they were very well founded for things like that. You need to publish it in some peer review security conference, and they were like, so you get some feedback. If you don't do that, then you won't have.
Or you could wait until you get hacked by the NSA.
Yeah, indeed, right? We could do that. But like, I'm talking about this stuff because this is stuff that we have on our horizon. This is stuff that we want to happen for Whisper and really for these other protocols that are being used in this context, right? It's very, very important for us as a messenger to make use of technologies that really work, right? And if they break, like, be public about it and open and sort of find a way to fix it. So last one, classic documentation, education, like on Whisper, there's practically nothing. I'm very happy that, Aaron, where are you? There, right? Showed me a nice documentation side of Swarm yesterday. I'm very happy to see that it exists. On Whisper, that doesn't really exist, so there's more work to do there as well. The final point is decentralization. Like, Boris mentioned the mail server trust issue itself. Like, we have to contact a particular mail server right now with the protocol as it is. It creates a single point of failure. It creates a single point of trust. Never good, right? Another issue we're looking at is like Whisper itself. It uses proof of work as a spam filter, basically. And that's fine when all the nodes on the network are entirely homogeneous, because, like, when they have the same computing power. For our case, a mobile phone, not quite the case. We don't want to burn battery just to like send an emoji to somebody. So that's also something that we're trying to sort of figure out how to do. And a big area of our ongoing research is like incentivization models, like where maybe you pay for a service to somebody that provides it, or like the other light clients work, that you have the possibility to pay for better service at some point. And those might be interesting things to explore in the future. You had something?
Yeah, so I was going to ask you, you talked about the performance challenges with Whisper. It seems like there's this inherent conflict between the desire for anonymity and surveillance resistance and performance to some degree, right? I was just curious to hear what things you could do to improve performance without sacrificing some of the reasons Whisper was created in the first place.
Yeah, so like you say, it tends to be a trade-off. Why I'm optimistic is because there has been improvements on this front over time, right? So if I look back at the situation in the early 2000s, forward secrecy didn't quite exist, right? And today it exists as a technology because somebody had a bright idea. That strictly improves security and at basically no cost, as each new technology does, right? I was reading a secure messaging paper the other day, and it increases, it affords the same kind of security for group chat, which until a year ago, like nobody knew how to do it. It's called something longer than just double ratchet, but it's double ratchet for group chat. Yeah, like those are examples, right? And the Bloom filter that we did right now gave us this massive reduction. Like, how much was it? 100 times, 1,000 times? Yeah. So, like from one point of view, sure, these are tricky issues, right? On the other hand, we keep finding new ways to make things better, right? And I think like a core responsibility of us is to bring these new developments to as many users as possible out there, right? So, and maybe that's also one of the ideas with Status itself, right? That it strives to be user-friendly. In fact, it's something, it's like my last slide there, like what else is going on at Status, right? It's a big company and we're doing lots of stuff and all kinds of things, but user experience is on my list there, right? And our idea of bringing these technologies to users is rooted in this belief that everybody should have access to these great technologies and maybe have a choice to use more or less privacy and so on, right? But that would be my answer to the question. It's not a pure technical answer. It's more like we're getting there. So last few words. I promised Yuri Matias that's working on the Embarked app framework. It's an app framework for developing apps. I promised him to tell you all that we're supporting Swarm there as well. We're supporting IPFS as well. It's an app framework to develop the apps, basically. It helps you with getting access to the protocols from JavaScript. A little bit similar to what I heard about the mainframe SDK yesterday. So you can deploy your dApp to Swarm or to IPFS. It has layers for messaging. It has layers for convenient access to other dApp features. We're building our own Ethereum client for research purposes called Nimbus. It's a new one. We're going to target it to light devices, right? So light protocols, light everything. Hoping to make it kind of modular so we can deploy it both on phones and maybe on custom hardware, mesh network nodes, you name it, right? But it's going to be customizable that way. That's the main selling point. There's Incubate. There's a bunch of other projects going on in Status that I encourage you to check out. I think they're pretty exciting. I've only been in Status for a month, and I still have a list to go through, like what's going on. And then, obviously, with all the great projects that I've been listening about today, right? So, that's it.